was the best time to go.
You had half an hour to leave, and I chose once I figured everything out. Oh, that's why it's screwed up. Okay, I got you now. Polynomials. When it comes to the rest of the test, I think perms and coms is like, I want to say 15% of the test. I actually think it's 16 technically. So very few perms and coms. That leaves you with like 50% of the test for logs, transformations, polynomials, rationals, radicals. So you're only looking at like a couple questions from each of those topics, because logs does take up usually a few of them. Transformations is usually just embedded throughout. Right? So when we talk about this unit, maybe like 1 or 2 questions per unit. Okay, just for when you're focusing or studying, I would make sure you can do trig. That's very important. Cool. Multiplicity. Multiplicity is one of the definitions that we learned in this unit. Multiplicity basically meant like how many factors of something you had. So if something had multiplicity 1, meaning there was only one factor of that thing, when it crossed through the x-intercept, we said it just went straight through it. Right? It slashed straight through, like right here. See how it goes straight through that x-intercept, straight through that x-intercept, straight through that x-intercept. That means when you make that equation, it's only got one factor of that x-intercept. An example for that one would be x plus 2, x minus 3, let's do 1, x minus 1, x minus 7. Right, that's 3 x-intercepts. There's an x-intercept at minus 2, positive 1, positive 7. All of them have multiplicity 1, meaning there's only one set of brackets for each one of those x-intercepts. Multiplicity 2 means that you have something like this, x minus 4, and then it's squared, meaning that there's 2 of those things. When you get that, you get a tangent point at the x-intercept, meaning it goes, touches the x-intercept, and goes back up. Like this. Down, x-intercept, back up. That tells me I'm talking multiplicity 2. Technically, it's just an even multiplicity. So it could be multiplicity 4, 6, 8, 10. It could be anything. Typically, we're talking multiplicity 2. This over here only has multiplicity 1, so this equation would be like x plus 3, right, with an exponent of 1, because there's only a slash through. And the third type of multiplicity is an odd multiplicity, like multiplicity 3. When you get an odd multiplicity, it makes that point of inflection. It like goes up, touches it, curves, and goes back up again. It makes this behavior, like up, touches, and then up. We call that a point of inflection. Cool, that means you have an odd multiplicity. So this, for example, could be like x minus 1 to the power of, let's say, 5. You might remember, like, throw back to a question on a test that we had where we had multiple multiplicities of 3 in a question, and you had to decide which one was multiplicity 3 and which one was multiplicity 5. You can tell by looking at which one is wider. So the wider it gets right at the x-intercept, the larger the multiplicity. If it's skinny, that means it's got a smaller multiplicity. I think I have an example of that coming up. If not, I'll draw one for you. Bueno. Next definition we had was something called degrees. Degrees means when you're in general form, the highest exponent. And that is in general form. All right, so if it's in factored form, you'd have to turn it into general form to find it. Odd degrees. Let's see if that follows. Odd create the same end behavior. End behavior is like where the graph starts and where it goes to. I like to think of it as odd degrees will eventually make a linear type system. So if you look at all those examples of odd degrees, and you were just to connect their tails, so tail, tail, you'll see it's making a linear trend. When you get that, it's telling you that the highest exponent is an odd number when you're in general form. You have an odd degree. All those are examples of odd degrees. Look at the tail, tail. If you just connected them and ignored everything in the middle, you see you're creating like a linear trend. Third one, same idea. End of the tail, tail, I'm making that linear trend. All of these systems have odd degrees. Because the overall trend of the graph is linear. That makes sense? Cool. Even degrees, when you connect the tails, create that like quadratic, that parabola look. So down here are examples of even degrees. If you were to connect the tails, the general trend, this one's clearly just a parabola. That means it's an even degree. Look at the second one. Look at the tails. The overall trend, it goes down, but then it goes up. Yeah, it does all kinds of things in between there, but that's the trend. It's making that parabola. Goes down, does a bunch of stuff, goes back up. Same with this third one. If I look at the tails and I connect them, it went up and then down. Right? Did all kinds of stuff in between, ups and downs all over, but the overall trend, it went up and then it went down. That tells me it's an even degree polynomial. And same with this last one over here, like that's very clearly a parabola. It's even degree. Perfect. Looking back at these examples, the direction of the trend tells you the leading coefficient. That's the number in front of the polynomial, the very first number on the highest exponent. If you have a positive overall trend, meaning it's going upwards overall, these have positive leading coefficients. Because they're going upwards overall. If you look at the other two, you'll notice that their trends are going down. These ones have negative leading coefficients. Remember, that's the number in front. When we're talking general form, right, like that's a leading coefficient. This is the degree. I feel like people are looking at me a little bit crazy as I use those terms. Same thing works for even degrees, right? So these are all even degrees because the overall trend's making that curve. If the overall trend goes up, those are leading coefficients that are positive. If the overall trend is down, they're negative. means just by looking at a graph, you should know like a decent amount about it. I should know the leading coefficient, whether it's greater than 0 or less than 0, positive or negative. I should know the degree of that function. I should know how many x-intercepts can factor out of it. I should even know the multiplicity of every one of those x-intercepts. Right, so you know a lot just by looking at a graph. Wicked. Let's do some questions. We're going to start with our good friend division. So we're going to do synthetic division and long division. If you remember, we would take polynomials and we were dividing them. That was always lots of fun. All right, we'll start with synthetic division, then we'll do long division. If it says that you have to use synthetic division on a written response, then you have to use synthetic division on the response. If it just asks you to divide, you can use whichever strategy you want. Synthetic division is where we do our little like hockey stick. On the outside of the hockey stick is the constant term from your divisor. So right here, I just go minus 2. Across the top of your little hockey stick, you're going to put the coefficients from all your terms. So like 1, 2, negative 3, 7. 1, 2, negative 3, 7. That's how you set up your synthetic division. Perfect. The very first number, you just drop it and put it right here. Perfect. Then you are going to take the negative 2, this value, you're going to multiply it by this 1 right here, and you're going to put that value in that spot. So it's negative 2 times 1, give me negative 2. You take those numbers on top of each other, you subtract them. 2 minus negative 2 is 4. And I repeat the process. So I take the negative 2 that's purple, multiply it by that green number. Negative 2 times 4 is negative 8. Again, we subtract. Negative 3 minus negative 8 is going to give me a value of positive 5. Multiply. Negative 2 times 5 is negative 10. 7 subtract negative 10 is positive 17. Those numbers on the bottom give you the answer to the question, x cubed plus 2x squared minus 3x plus 7 divided by x minus 2. From right to left, this is my remainder. The other 3 values create a polynomial for you. They're the coefficients of the polynomial. This would be my x squared term, this would be my x term, this would be my constant term. So my answer would be 1x squared plus 4x plus 5 with a remainder of 17. Yep. Good question. When you divide into it, typically you end up going down 1 in degrees. I think actually, I'm almost confident to say always. Cool. For the record, you could also write your remainder as 17 over x minus 2. And I could do like plus that as my remainder, because that's what's left over, right? I still had that 17 divided by x minus 2 that I couldn't divide. I'll do that for the next one so you can see what it looks like. Actually, the next one might divide perfect, but we'll see. Synthetic division was probably like, I don't know, a 3/4 of your guys' way to go. You all like synthetic more. The perks of it, it's faster. It's cleaner. It's like more organized. Downfalls of it, you can't see the values, like it's just constant terms, which sometimes freaks people out because the variables are all gone until the very end. And it only works if there's no a value on the divisor. So notice that up here, like there was an a value of 1. If there's a value there, you can't use synthetic division. So that was probably the biggest downfall of synthetic division. Like if you look at question 2, like I could not use synthetic division because of that 2. Yeah.
They would never try to trick you by saying use synthetic division.
No. Technically, you could use synthetic division on it, but for our course, they're never allowed to ask you that. You only have to use synthetic division with an a value of 1. If you have a value there, we do the long division. So to set up long division, we go 2x minus 3 divided into 2x cubed plus 5x squared plus 4x minus 8. That looks like a root sign. I don't want it to look like a root sign. Alright, how synthetic division works. How long division works. Your focus is going to be on making this first term equal that term. If I wanted 2x to become equal to x cubed, I would have to multiply by x squared. Agreed? If I had 2x and I multiplied by x squared, it would become 2x cubed. Cool, so that's what we're going to do. We're going to take that 2x minus 3, we're going to multiply it by x squared. That gives us 2x cubed minus 3x squared. Right, that's a result after I multiplied it by x squared. Whatever I multiplied by goes on the top. The result is in green there. I then subtract these polynomials. 2x cubed minus 2x cubed is 0. Perfect. 5x squared minus negative 3x squared is 8x squareds. Remember, we're subtracting. 4x minus nothing, because there's nothing below it, is still plus 4x. Negative 8 minus nothing is still negative 8. You might remember from way back when people would just draw arrows and they would say drop those things. It's just because there's nothing to subtract them by, right? That's why they drop down, because you're subtracting 0. Then repeat that exact same process. Focus on your first term of your divisor, 2x. I want it to be the same as 8x squared. To make it the same as 8x squared, I would have to multiply by positive 4x. When I multiply by positive 4x, I get 8x squared minus 12x. Subtract these two polynomials. 8x squared minus 8x squared will cancel out. 4x minus negative 12x will give me 16x. Minus 8 minus nothing is minus 8, negative 8. And repeat the process one more time. 2x, I'm going to have to times by 8 now. Will give me 16x minus 8, 16, 24. And subtract. (16x minus 16x) gone. Negative 8 minus negative 24 is going to give you positive 16. That is your remainder. To write this answer, the thing in blue is your solution, with a remainder of 8, so you might put R8. You could also write it like, remainder of 16. You could put R16. They might also write it like this. Plus, you still have a 16 divided by 2x minus 3 left over. Same idea. It's showing you a remainder as a fraction. So it's my remainder divided by this. That's still sitting here left over.
Both of those are okay on the diploma, right?
Yeah, but if it's like multiple choice, they might write it with an R, but they also might write it as a fraction. And I want you to get there and see that fraction and be like, what is that? Right? They're just showing you like this part didn't divide, so you still have it on the side. I do expect one of those questions will be on the diploma. You'll get a long division or a synthetic division. Fingers crossed, because honestly, you'll probably do pretty good at it. Yep.
So you write the 16 divided by 2x minus 3, or did you write remainder of 16?
Both would be legit, like that's what I'm saying. So like you could do this as well. If it was multiple, if it was written response, both of these would be good. Both are good. If it's multiple choice, they'll choose. Only one of them will be there. Okay, let's look at a factoring question. It's a little bit of a weird factoring question. We have x to the power 4 plus x squared minus 20. You can factor that. It's a trinomial. So what's our strategy for factoring a trinomial? Diamond method. And you can diamond method that thing. So you're looking for things that multiply to be negative 20 and add to be positive 1. Things that multiply to be negative 20 and add to be positive 1 are 5 and negative 4. The difference here is when you factor this, normally we would say x plus 5, x minus 4, but that's not going to work here. The reason that's not going to work here is because I need x to the power 4 as my first term, and I need x squared as my middle term. This would not create that. The only thing different here is making sure that these values create this. So instead of x and x, I'm just going to make them x squared and x squared. And that is now factored. X squared plus 5, x squared minus 4. I almost boxed that up. Are we okay with that diamond method? Cool. Why is it not done factoring?
You can do it at square root.
Yeah, that's sneaky. I didn't even see that coming. This thing is a difference of squares. I can square root that thing. So, square root x squared and 4, and I get x minus 2, x plus 2. That's factored. All right, number 4. We talked about like potential zeros in this unit, so like trying to predict where x-intercepts might be when you look at a polynomial, and trying to predict things that might factor into something, that might divide into a polynomial. The way that you can do that is by looking at something called your potential zeros or possible zeros. I call them potential. To find your potential zeros, you're going to put all the factors of the constant and you're going to divide that by all the factors of the leading coefficient. So these are places that you might have an x-intercept. Factors of the constant. That's values that could divide into positive 12. 1. Start with that one. Technically, negative 1 would also work. So I go plus minus 1. 2 can divide into 12. Technically, negative 2 can as well. 3 can divide into 12. So positive negative 3. 4 can divide in. So positive negative 4. 6 can divide in. And 12 can divide in. Those are all possible factors of my constant term. I then divide that by possible factors of the leading coefficient. The leading coefficient here is just 1. The only thing that can divide into that is positive or negative 1. Anything divided by 1 is just staying the same. Agreed? So the dividing by 1 isn't going to make a difference here. My possible x-intercepts or my possible zeros are all these values. Positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 12. I believe that's the last answer down there. It is. The answer here is D. That tells me where there might be x-intercepts. It's a lot of locations. Cool. Number 5. The graph of a polynomial function f of x equals x plus 4, x minus 2, x plus 6 is transformed by a horizontal stretch by a factor of 2. Which of these statements are true? The new zeros are at, the new zeros are at, the new y-intercepts, the new y-intercept. Okay. First off, ignoring this question for a second, let's talk about this polynomial. Things I know about this polynomial. What's the degree of it? Yeah, it's degree 3. The way you know it's degree 3 is if you put this thing in to general form. X times x would end up giving you your first term. That is x to the power of 3. So yes, the degree is 3. The leading coefficient. Last one. Life. I feel you. You just wait to see the things we do in this room and tell Blinky it was you. What? Don't worry about it. Put in that work. Your shoes untied. We'll miss you. I think Ethan hates me. He just hates me. He's got to get a haircut? Oh, yo, that's important. That's important.
He really doesn't understand what put in that word.
He did not know. He did not get that. No. Yeah. It just added the hate, I think. Okay, your leading coefficient. Your leading coefficient comes from, like, those first terms all multiplying together, right? So this would be 1x squared times 1x squared times, 1x times 1x times 1x, which would give you 1x to the power of 3, meaning the leading coefficient would be 1. Perfect. With just that info, I know that my graph should have an end behavior that is linear and increasing. If I was to graph it, it's got to make that pattern. It's going to do other things in between, like I understand that, but the end behavior, looking at those tails, it's going to go from quadrant 3 to quadrant 1. It's going to make that pattern. It's increasing because the leading coefficient is positive. The degree is odd. So overall, it's going to make that trend. It's going to look a lot more like this. Actually, let's talk about x-intercepts first. Where would the x-intercepts of that thing be? Yeah.
-6, -4, and +2.
Yeah, it would be at -4, +2, and -6. I'm just doing them from left to right. You did least to highest. That works too. Doesn't matter. That means my graph, while making that trend, is going to hit those points. It's going to have an x-intercept over here, another x-intercept here, another x-intercept here. So maybe it looks something like this. Up, down, up. But overall, notice there's my linear trend. And it's going to hit all 3 x-intercepts, and it's going to slash through all 3 x-intercepts. Because all those are multiplicity 1. You throw in your graphing calculator, you'll see that sketch isn't actually that far off. Right? It is actually that trend it makes. It goes a little bit lower for the y-intercept, but it's actually not that far off. It does go up, makes that first parabola, goes down, makes another parabola, and goes back up. Cool. Now let's try to answer the question. Okay. It says that equation is transformed by a horizontal stretch by a factor of 2. All right, that means x values are multiplied by 2, not 1/2. If I was to write it in function notation, it would look like this. But the actual effect is a multiplication of 2. Cool. Would that have any effect on my y-intercept? No, your y-intercept has an x value of 0, right? Multiplying x by 0 is not going to change anything. What it will move is it'll move my x-intercepts. So that means my x-intercepts are going from -4 to -8, from 2 to 4, from -6 to -12. Multiply the x-intercepts by 2. The answer is A. Notice I did not make a new equation and then try to graph it and find the x-intercepts. That is a much harder thing to do. I'm just using my transformation on specific 3 points. Much easier. Awesome. Number 6. Which of the following is a factor of f of x equals that whole polynomial there? That means which of these could divide into that polynomial? Now you could try dividing it in to all those, and that would be awful, right? Or we could use something called the factor theorem. I almost never call it that, but the technical term is the factor theorem. You can test these x-intercepts, like test when x equals -2. If it works, then the whole function should equal 0. If it doesn't work and it's not a factor, it won't equal 0. So try it. Change x to be -2, see what happens. 4 times -2 to the power of 4 minus -2 cubed minus 8 times -2 squared minus 40. When you put that in your calculator, Blinky's got a calculator. Must be nice. 4 -2 to the power of 4. This thing is old school, though. You know, I don't know if I know how to use this. To the power of 3. -2 squared minus 40 equals 0. Perfect. That means negative 2 is an x-intercept, which means x plus 2 is a factor. If you want to see one that doesn't work, let's try testing x equals 4. So go to your equation, change x to be 4. You throw that x value in. Oh, look at me, I'm a genius. And you get 792. That means that is not an x-intercept. That means that is not a factor. It does tell you that the point 4, 792 exists, but it's not a factor. So that would not work. If you tested C and D, they wouldn't work either. Yeah.
Can you also do it by doing like the factors of the constant divided by the a value to get the potential like zeros that you could have, and
Yep.
then compare those to what you get?
Yeah, and that would work too. So if you wanted to check your potential zeros, there's a lot of them, because things that divide into 40 is 1, 2, 4, 5, 8, 10, 20, and 40, and then divide all those values by 4, which actually isn't that bad because they're all there's a lot of fractions and then some whole numbers. This one won't be there. Negative 8 won't be a potential. Positive 6 won't be a potential. 4 could be potential because 20 divided by 4 would be 5. No, 20 divided by 5 would be 4. So this would be a potential one.
But it's 20 divided by 4 would be 5.
But remember, you could do positive or negative factors too. So you can imagine negative 40 divided by positive 5.
But it's divided by 4.
Sorry, it is divided by 4,
Yeah.
which is 5, which is not 4. Yeah, no, you're right. And then the only potential zero would be 2. Or negative 2. Yeah, you got it. That's smart. I like it. All right, number 7. If that polynomial is divided by 2x minus 1, the remainder is a over b. Place the value of a in the first numeric response box, followed by the value of b. That is a good division question for a diploma question. Right? So it's like there's no guessing and checking here. You got to be able to do it. You know your answer should be a fraction, which that's nice. And then just do it. Like, can you figure it out? We have to use long division. The reason we have to use long division is because it's a 2. So let's long divide. The trick to this one is when you do your 2x minus 1, that's fine. You do your division symbol, life is good. I put x to the power of 4, but then I don't put minus x, 3x. I put plus 0x cubed plus 0x squared. Then I put negative 3x. Then I put plus 5. I put placeholders in for the terms that actually have a 0 there. If you did synthetic division, which you can't for this question, but if you did synthetic division for something similar, you would put zeros as the constant values. So you do need to include placeholder zeros. I'm going to go through this decently fast. Okay, so the first thing I'm going to have to multiply by for that 2x to become x to the power of 4. Oh, that's ugly. There's no way I'm going to make that nice. I'm going to have to multiply by 1/2 x cubed. Yuck. That would give me x to the power of 4 minus 1/2 x cubed. Subtract. That gets you the x to the power of 4s. 0 minus negative 1/2 will give me positive 1/2 x cubed. Drop the 0, x squared. Drop the negative 3x. Drop the 5. Repeat the process. I want 2x to become 1/2 x cubed. That means I'm going to have to multiply it by positive 1/4 x squared. Two times 1/4 would become 1/2, right? 2 divided by 4 is 1/2. That gives me 1/2 x cubed minus 1/4 x squared. And subtract. I'm going to run out of space. The x cubes go away. 0x squared minus negative 1/4 x squared will give me positive 1/4 x squared. And then I still have my other term sitting here. Minus 3x plus 5. Continuing on, I need to multiply this by now positive 1/8 x. That will give me 1/4 x squared minus 1/8. Subtract. I'm going to write at the top here. 1/4 minus 1/4, that goes away. Negative 3 minus negative 1/8. Utilize your calculator for that. All right, so typing in your calculator, you just go negative 3. Down here is your negative symbol, right? Negative 3 minus bracket negative 1/8. You get a decimal value of negative 2.875. Math frac that. And you get negative 23/8x plus 5. Perfect. Make the 2x become negative 23/8x. If you're unsure of how to do that and you want to make those things equal each other, where can I write this on the side that's not going to get in the way? I'm going to do it in the top left-hand corner. You want 2 times something to become negative 23/8. You just have to divide by 2. Yep.
When you multiply by 1/8x, do you have to have the x on the...
Oh, right here?
Yeah.
Yeah, that definitely make it neater. Okay, so in your calculator, if you put in negative 23/8 and divided it by 2, that tells you what you have to multiply by. So for us, math frac that decimal, I had to multiply my last thing by negative 23/16. That would give me my terrible negative 23/8x, and then plus 23/16. And then subtract. Again, these things will cancel out. Now I'm going to calculate my remainder. So 5 minus 23/16. Math frac that. 5 minus 23/16 gives you 3.5625. Math frac. I get 57/16. This is my remainder. They said put the value of A first, 57, put the value of B second, 16. That's an excessively hard division question. That's terrible. Yeah. I almost feel like it's a typo. All right. Number 8. If P at negative 4 over 3 equals 0 and P at 2 equals 0, then the second degree factor of P of x is. Okay, when they said these two things, those are x-intercepts. They equal 0. That means your function must look something like this. 3x plus 4, x minus 2. See ya. I know that, right? Because if I put this into the first brackets, the 3 divided by 3 would cancel out. Negative 4 plus 4 would equal 0. It would give me an x-intercept. If I put 2 into the second brackets, 2 minus 2 would be 0. That gives me an x-intercept. So these two things told me that this exists. Technically, there could be an a value out here. Technically. We're not going to put one. Because they're just asking us for a second degree factor, so they're talking about just the factors. But if I was creating an equation, I would put an a in front. I'm just creating the factors. Those are the factors. You look at your answer, none of them match. All your answers are in general form. So all you need to do is multiply those things together, and that will tell you your answer. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. 4 times x is plus 4x. 4 times negative 2 is negative 8. Combine those middle terms. My answer is 3x squared minus 2x minus 8. That is A. Realizing that these are x-intercepts was key. Let's keep going. Number 9. The equation of a polynomial function shown below, assuming a, b, and c are positive integers, could be. Looking at this guy, I've got some x-intercepts here. Right there, right there, right there. Those tell me that my function must have x plus 3, x plus 1, x minus 3. Those must be the three factors. Cool. Now do the multiplicity for those factors. Looking at the first one, notice that it makes our little quadratic here. That tells me I have an even multiplicity for that spot. It could be 2, 4, 6, 8, any of those things. Typically, we just make it 2. Makes life a little bit easier. Looking at the second one. The second one makes that nice linear trend through it. That means it is multiplicity 1. If it was a point of inflection, you would see more of a curve and a curve. It would look more like this. Like it would go up and then flat and then out. You'd see more of that trend. It doesn't make that trend. Right? There's no elbows in there. That just goes pretty much straight through. If you look at 3, the purple one, that's very clearly just a slash right through it. Alto multiplicity 1. So this is x plus 3 squared, x plus 1 to the power of 1, x minus 3 to the power of 1. They didn't put values, they put a, b, c. So it would be b. Oh, I'm a liar. Why am I wrong? Yeah, there's a negative leading coefficient here. I have an overall trend that is looking like this, meaning it is down, meaning I need a negative first value. If I looked at this current equation that I created, x times x times x would make a positive 1. So there's definitely a negative in front. The answer is C. I would have got that wrong. Actually, maybe not. I looked at the answers, and I saw that, and I was like, why is that not the same as that? Right, like, those two patterns are like identical, which hopefully should then signal to you, oh, that's sitting there. So maybe double check. Okay, something else important in the debate of is that second one multiplicity 1 or multiplicity? No, it's not going to help. Never mind. Cool. 10. The graph of a polynomial function of the form a x minus x, x minus q, x minus r has x-intercepts of -1, -2, and 4. The y-intercept is 32. The value of a is. Finding your a value. This is something that we've been doing for 2 years. We had to do it 20-1 as well. Okay, when they give you these values, those values match up to S, Q, and R. So I can replace them to look like this. P of x equals a. X minus -1 would be x plus 1. X minus -2 would be x plus 2. X minus 4. Right, they gave me my factors, my x values, my x-intercepts. The only way you could find an a value is if you knew another point that you could use as x and y values. Hence, their random inclusion of the y-intercept. They are giving you an x value of 0, a y value of 32, so that you can go and solve your a value. This becomes 32 equals a, 0 plus 1, 0 plus 2, 0 minus 4. Some quick math here. Those things all multiply together. So 1 times 2 times -4 is -8. Divide -8 to the other side. 8, 16, 24, 32, -4 equals a. Answer is C. Good? Okay, don't look, but there's deer outside running across the street. Fine, just me. Okay, I'm really excited. There were 6 of them crossing the other day. I sat here forever trying to get out of the parking lot watching 6 deer cross the road. Just a line of traffic both directions waiting. We did that once on Highway 11 for like a family of geese. You know, like the geese are always are hanging out on the side of Highway 11. I don't know if you ever noticed that. There's a ditch, but they were crossing one day. And it was like middle of the day. And it literally, Highway 11 was backed way up. I was like, gotta be a car accident. Nope, just a family of geese. It was like slowly going across the street. That's brilliant. Yeah. Yeah. Stop for your friendly animals. Let's look at this guy. What is the minimum possible degree for that polynomial function? You get your degree from the x-intercepts, right? Look at the behavior of your x-intercepts. This one slashes through, so that's multiplicity 1. This one slashes through, that's multiplicity 1. This one makes that little tangent point, that's multiplicity 2. That means the possible degree, minimum possible degree, is 4. Because I would have an x times an x times an x squared. I say minimum because technically we don't know if this is multiplicity 4, 6, 8, 10, 12. It's an even multiplicity. All right? The minimum, smallest it could be, though, is 2. Easy money. Light work. Number 2. When the above function is factored, it is expressed as, same picture above. My bad. I knew even when I was making that yesterday, I was going to screw that up today. But it just worked better for the way that the paper fit. You know, I didn't want to waste paper. Trees matter. When the above function is factored, it is expressed as f of x equals negative a, x plus b, x minus c, x minus d squared, where a, b, c, d are all positive. The value of a in the form p over q, so it's going to be a fraction, is. Let's make this thing. b is going to be negative 3, c is going to be positive 1, and d is going to be positive 4.5, I believe? Looking at it. Nope, positive 5, sorry. So I can start with this. Oh, my bad. I got all those positives and negatives wrong. There we go. Right? My x-intercepts into my factored form. My goal now, find an a value for that function. To find your a value, you need a random point from this graph. I actually thought, maybe it's a future question, that it was labeled. Let's go with this guy right here. It's typically the y-intercept. That's at 0, 5. We'll label it. So to find your a value, use that point as your x and your y. So y was 5, x was 0. Now I can figure out what a is. That's 5 equals negative a. 0 plus 3, 0 minus 1, 0 minus 5 squared. Quick calculation of those things. 0 plus 3 is 3. 0 minus 1 is negative 1. 0 minus 5 squared is 25. Positive 25. Little more quick math. Multiply those things together. I have 5 equals negative a. 3 times negative 1 times 25 is negative 75. Divide that negative 75 to the other side. As a fraction, you have 5 divided by negative 75. Both those numbers can divide by 5. And I believe you get negative 1 over 15. Equals negative a. The negatives do cancel each other out. All right, I could just make both of them positive by multiplying both sides by negative 1. So a is negative 1 over 15. Or sorry, positive 1 over 15. Numeric response, so they just wanted the values of a, p and q. We all right with that? All right, number 3. If x plus 2 is a factor of that whole thing, then the value of k is. Okay, is a factor. Is a factor means negative 2 is an x-intercept. Agreed? If negative 2 is an intercept, that means I know that this point, negative 2 comma 0, exists. That means, going to my equation, I now know x equals negative 2, y equals 0. Now I can figure out what k is. I used to have this saying of like, one unknown requires only one equation to solve it. And if you had 2 unknown letters, you would have to have 2 equations to solve it. There was only one unknown here, just k, and only one equation given. That means I must know values for the other letters. X was negative 2, f of x, which is y, is 0. Throw those values in, and we have 0 equals negative 2 cubed plus 3 times negative 2 squared plus k times negative 2 plus 4. Some quick math here. Negative 2 cubed is positive 8. Nope, negative 8. 3 times negative 2 squared is positive 12. Plus k times negative 2 is negative 2k. And plus 4. A little bit more quick math. Negative 8 plus 12 plus 4 is going to give me 8 minus 2k. Move our 8 over. I have negative 8 equals negative 2k. And divide by negative 2. 4 equals k. Done. We'll do radicals and rationals tomorrow. There is some